Alright, so we've got an absolute value function here. So if you think about it without the absolute values, we've just got x plus 1, x minus 3, and if I expand that, I get x squared minus 2x minus 3. So this original, we already know that the zeros are -1, and so that's -1 and 3. Therefore, the axis of symmetry right in the middle, so at 1. So let's say it goes something like this, and then we know that the absolute value of that is we want everything positive. So we want this part, that's fine, that's going to stay the same. This part, it's going to stay the same. So the only part that's going to change is this part here, so it's going to be reflected, there we go, and so it's going to have, if I sub in 1 here, I get a 2 and a -2, which is -4, absolute value is 4, so that's going to be a 1, 4 there. This was a 1 minus 4 here. Alright, so it's just the part above the x-axis. Now, if we were interested in the derivative function, so for the pink bits, of course, it's just going to be the normal derivative function. We didn't even need the absolute value for those bits. So if I just differentiate here, I've got 2x minus 2. So that is going to be the gradient function for where x is less than -1 and for where x is greater than 3. At these points, -1 and 3, they're critical points. They're undefined for, we can't do a gradient function there because they're undefined at those points. They're critical points. All right, so what about for x's between -1 and 3? What would y dash be? Well, if you think about it, if I just turn the whole parabola upside down, so it would just become the negative of this. So it would become, I'll do it in green, so y equals -x squared plus 2x plus 3, right? Because it's just the upside down, and I'm only doing this for part of it, but differentiate that and I get this gradient function. All right, so you can see that the gradient is, if I go, I've got no other colour here, so I'm decreasing, I'm increasing up to here, I'm decreasing, and I'm increasing up to here. So we won't bother drawing a table of slopes. We've already got all the information to describe the curve.